Welcome to our exciting journey into the world of food chemistry. Have you ever wondered what makes your favorite bread so deliciously brown, or why yogurt tastes so tangy? In this lecture, we'll unravel the mysteries behind the chemical reactions that transform simple ingredients into the flavorful foods we love. Get ready to discover the science that makes your meals not just edible, but extraordinary. Introduction to food chemistry. Food chemistry is the study of the chemical processes and interactions of biological and non-biological components of food. Understanding these interactions is crucial for food processing, preservation, and safety. Food chemistry helps in maintaining the quality and safety of food products. Knowledge of chemical reactions aids in enhancing flavor and aroma. Understanding chemical structures allows for better assessment of food's nutritional contributions. Carbohydrates. Organic compounds made up of carbon, hydrogen, and oxygen, typically in a ratio of 1 to 2 to 1. Simple sugars like glucose and fructose, which provide quick energy. Composed of two monosaccharides, such as sucrose, also known as table sugar, and lactose, which is milk sugar. Complex carbohydrates like starch and cellulose, which serve as energy storage and structural components. Carbohydrates are the primary energy source in diets. They contribute to the texture, like starch in bread, and stability of food products. Proteins. Large, complex molecules made up of amino acids containing carbon, hydrogen, oxygen, nitrogen, and sometimes sulfur. Sequence of amino acids. Folding and coiling of the amino acid chain, such as alpha helix and beta-pleated sheets. Three-dimensional structure formed by further folding. Assembly of multiple polypeptide chains. Essential for growth and repair of tissues. Proteins affect the texture, flavor, and nutritional quality of food, like denaturation in cooking. Fats and oils are lipids that are soluble in organic solvents but not in water. They are composed mainly of fatty acids and glycerol. There are different types of fats. Saturated fats have no double bonds between carbon atoms like butter. Unsaturated fats have one or more double bonds, such as olive oil. Fats play a crucial role in food. They provide a concentrated source of energy, which is essential for our bodies. Additionally, fats enhance the mouthfeel and flavor of food, making them important in baking and cooking. Vitamins and minerals are essential nutrients that our bodies need to function properly. Vitamins are organic compounds that are crucial for various metabolic processes. They are classified as water-soluble, like B vitamins and vitamin C, or fat-soluble, such as vitamins A, D, E, and K. These vitamins are vital for maintaining health, supporting immune function, and enabling energy production. Minerals, on the other hand, are inorganic elements necessary for physiological functions. Examples include calcium, potassium, and iron. Minerals are important for bone health, nerve function, and enzyme activity. Chemical reactions are at the heart of food transformation. They play a crucial role in everything from cooking to preservation, affecting flavor, texture, and safety. Let's delve into some key types of reactions that occur in food. Hydrolysis is a chemical reaction in which water is used to break down a compound into smaller units. This process is vital for digestion, as it helps our bodies convert complex carbohydrates, proteins, and fats into simpler forms that can be absorbed. For example, when you chew bread, enzymes in your saliva like amylase begin breaking down starch into simpler sugars like glucose. This is why bread tastes slightly sweet when chewed. The reaction can be represented as starch plus water acted upon by enzymes yields glucose. Fermentation is a metabolic process that converts sugars into acids, gases, or alcohol using microorganisms such as bacteria or yeast. It occurs in anaerobic conditions or without oxygen. Take yogurt production, for instance. In yogurt, lactose, which is the sugar in milk, is fermented by bacteria such as Lactobacillus bulgaricus and Streptococcus thermophilus, producing lactic acid. This acid thickens the milk and gives yogurt its tangy flavor. The reaction can be summarized as lactose acted upon by bacteria yields lactic acid. The Maillard reaction is a complex chemical reaction between amino acids and reducing sugars that gives browned food its distinctive flavor and color. This reaction occurs when food is heated, particularly in baking and roasting. For example, when you sear a steak, the heat causes the Maillard reaction to occur, creating rich flavors and a brown crust. This not only enhances taste, but also creates appealing aromas. The reaction can be summarized as reducing sugar plus amino acid acted upon by heat yields flavor compounds. Understanding these reactions is crucial for food technologists, as they can manipulate conditions to achieve desired outcomes in food products. Here are some implications. A. Hydrolysis in food processing. For example, in the production of high-fructose corn syrup, starch from corn is hydrolyzed into glucose and then further converted into fructose. This process enhances sweetness and is widely used in beverages and processed foods. B. Fermentation in food production. For example, the production of sauerkraut involves fermenting shredded cabbage with salt and bacteria. This process not only preserves the cabbage but also enhances its flavor and nutritional value, making it a staple in many diets. C. The Maillard reaction in cooking is quite fascinating. For example, in baking, the Maillard reaction contributes to the golden brown crust of bread. Bakers can adjust the temperature and time to achieve the perfect color and flavor, making the bread not only more appealing but also more flavorful. By mastering these chemical reactions, food technologists can improve the quality, safety, and flavor of food products, creating better experiences for consumers. In this lecture, we explored the foundational aspects of food chemistry, particularly focusing on the critical chemical reactions that transform our ingredients into delicious meals. We examined hydrolysis, fermentation, and the Maillard reaction, understanding not just their mechanisms, but also their significance in food processing. From the sweet taste of freshly baked bread to the tangy delight of yogurt, these reactions are behind the magic of food. By grasping these concepts, you're equipped to appreciate the science that makes our food enjoyable and nutritious. As we continue our journey in food science, remember, each bite you take is a result of fascinating chemical transformations. So let's keep exploring the incredible world of food chemistry together.